Okay, Bismillahirrahmanirrahim. So this is the second unit to prepare the solution, and is called the molality. And you can represent with the small m, and by definition is the molar concentration. And what is the molar concentration? Is the amount of the substance dissolved in a certain mass of the solvent, and it is defined as the moles of the solute per kilogram of the solvent. This is similar to the molarity, which we have discussed right now, and molarity is shown by the capital M. So what is the difference? Difference is the capital M, or the molarity, is represented per liter of the solution, and here this is the per kilogram of the solvent. So this is not the liter, this is the kilogram, and here it is not the solution, it is the solvent. And what is the similarity? Similarity is the number of moles in the both concentration units, molarity and the molality. The number of moles of the solutes are, you have to use the number of moles of the solute in both of the cases. So this is the similarity, and this is the difference as compared to the capital M. So again, the unit R you can simply represent with the small m, or you can show with the mole per kilogram. And equation is, you have to convert the mass of the solute into the moles of the solute, and then you have to convert the ml, or the mass of the solvent, into the kilogram, the mass in kilogram of the solvent. So this is the basic conversion, and let's see what are the way to calculate these units. So one data is given, what is the molality of 85 gram of sodium hydroxide in 1 kilogram of the water. So let's suppose this is one of the data, and very basic information is given. That means first you have to calculate the molecular mass, and this is the way you can calculate the molecular mass by summation of the individual masses of all the elements, atoms present in the solute which you are going to prepare. And then by the definition, now you have to convert into the moles, and the moles are the given mass of NaOH divided by the molecular mass, and the given mass is the 85, and divided by the molecular mass is the 40, and this is going to be when to solve this one, the number of moles are 2.125 moles of the NaOH. Now you can calculate the molality. Simply it is 1 kilogram of solvent is given. That means this doesn't need any further conversion. So 2.125 moles of NaOH divided by 1 kilogram of the solvent, and this will remain the same. That means the molality is 2.125 molar, or you can represent 2.125 mole per kilogram. So this is the very basic conversion, and as explained in the molarity, I'm just showing you again the back conversion. You can also use this formula, and further you can watch the previous video. This is the same way. Here you just put the mass in kilogram, and here, like here, and then this is going to be shown as the molality. So the difference is this is the volume of the solution, and in case of the molarity, this is the kilogram of the solvent. So the change is there. And again, as explained in the conversion, I just use these two formula. First, I calculated the number of moles, and then just the number of moles divided by the per kilogram of the solvent by using the molality. Or you can also use this conversion, the way of the conversion to convert the gram into the moles or the kilogram or the volume into the kilogram of the solvent. So you can either use this or you can use this or you can use any of the formula according to your need. So I'm coming back to the molality, and here I have explained by using the first to calculate the number of moles and then molarity. And you can use any of the way which is better for you, the way you can better understand to calculate the molarity. Let's see another example. This is the data is given molality of 0.75 mole of NaOH in 500 ml of the water. So again, maybe if the mass is given, you can convert first the mass into the mole. But here, what is the difference between this exercise and the previous one? In the previous exercise, the mass was given, so you have calculated into the number of moles first, but there was no need for the second part of the calculation. Here, 1 kilogram of water, that means 1 kilogram of solvent is already given. But here in the second example, the number of moles are given, so there is no need to further calculate the first part, but the second part needs the conversion because the volume is given and you have to convert this volume into the kilogram of the solvent, and of course water is the solvent. So the first now there is no need for conversion in the first part, and you need to convert this volume into the kilogram. So this is the way. How can you convert? You can use simple density formula. Density is the mass by volume, and the mass will be equal to density into the volume. And you know, for the density of the water is 1. So that means 1 gram per ml, and the volume is given, volume is the 500 ml, and you have given over here the volume 500 ml is cancelled out, what is left, gram is left. So the mass is the same as the volume 500 gram because the density is 1. So let's suppose if you have any other solvent, then the density would be the difference. So just multiply the density with the volume. You can directly convert the volume into the mass. And in case of water, there should be the same mass as the volume is given because the density of water is 1. Now, the mass is given. Now you have to convert this mass in gram into the kilogram. And you know 1 kilogram equal to 1000 gram. Again, unit cancellation method, 500 gram. 1 kilogram is equal to 1000 gram. Gram is cancelled out. What is left? Kilogram is left. And when you solve this one, that is converted into the 0.5 kilogram of the water. So you have achieved the conversion 0.75 moles and 0.5 kilogram of the water, and the molarity is moles per kilogram of the solvent. And simply by using the molarity, 0.75 moles of the NaOH per 0.5 kilogram of the water or the solvent. When you solve this one, the answer is 1.5 m, small m, or 1.5 mole per kilogram. So this is all about the molality. And now just I'm going to compare between the molarity and the molality, what we have already discussed and its importance. If you consider the measurement, this is shown by the capital M, this is shown by the small m, and by measurement, of course, this is the concentration unit, and this is also a concentration unit. By definition, this is calculated as the number of moles of the solute per liter of the solution, but this is the number of moles of the solute per kilogram of the solvent. This is capital M, this is small m. By equation, again, very simple, moles, you have to calculate the number of moles of the solute per liter of the solution. And here you have to calculate the number of moles of the solute and kilogram of the solvent. The ratio of moles to here, this is the volume in liter, and this is the mass in kilogram. The same is given over here. That means the liter volume in liter, and this is the mass in kilogram. This is the important observation over here about the molarity and the molality. And molarity is the temperature dependent. That means when you increase the temperature, there may be the expansion in the volume. And when the volume will expand, it is going to affect on the concentration of the molarity, because this is the moles of the solute per liter of the solution. So if there is the restriction while using the molarity, if you are working in a temperature variation atmosphere, then it is better to use the molality, because this is going to be dependent on the temperature. So each time there is the variation in the concentration as per rise of the temperature or the decrease in the temperature. But the molality is the temperature independent, because whatever you increase the temperature or the temperature is risen, then there may be the expansion in the volume, but this expansion is not going to affect the mass of the solvent. The solvent may be expand and the contract, but there would be no change in the mass of the solvent. So molality will remain independent with the influence of the temperature. So this is one of the drawback of the molarity. But when there is no change in the molarity, usually when there is no change in the temperature, so we recommend to use the concentration unit in capital M, that is the molarity. And molarity, you have seen the importance of the molarity during the colligative properties, and there we use the term molality, and you can calculate the molarity by elevation in boiling point or the depression in freezing point. There we actually calculated the molarity by using different data. So this is the comparison between these two very important terms to be used to prepare the solution.